All right, if they give me a function like h of p is equal to p squared plus 2p, and they ask me to find h of 4, that is function notation. What they want me to do, if you line this up, you can see how 4 is in the place of p. That's exactly what they want me to do. They want me to put 4 in the place of p. So I'll come over here, and everywhere I have a p, I'll replace that with a 4. And then I'm going to follow order of operations to simplify. So 4 squared is 16, plus 8 is going to give me 24. All right, for the next one, it says evaluate when g of m is equal to 2. Now notice the difference between what we just did and this one. In the last one it said find h of 4. It was putting 4 in the place of p. This doesn't say find g of 2. This says find out where g of m is equal to 2. So if you'll notice back here, we plugged in 4 and we found 24. 4 was our input value, 24 was our output value. We weren't working with x and y, but it would be like we put in 4 for x and we got 24 for y. So what they're saying here is your y value is equal to 2. Your output is 2. What's your input? All right, so if you'll notice, since g of m is equal to 2, I'm going to replace g of m with 2. So now I'll have 2 is equal to the square root of m minus 4. So how would I get m by itself? Well, first I would square both sides, and then I could add 4 to both sides, and I would get m is equal to 8. So when m is 8 for my input, then I get 2 for my output. All right, look at the next one. The next one says express this relationship as a function where p is a function of n. So another way to see this is see how p is by itself? They want me to solve for p. They want me to get p by itself, and once I do, it will be expressed as a function that's only in terms of n. It's only using the variable n. All right, so let's get p by itself. How would we do that? Well, first we would subtract 2n from both sides. And then to get p by itself, we would divide by 6. So we would end up with 12 over 6 minus 2 over 6n, or you could reduce that. 12 over 6 is 2, and 2 over 6 is 1/3. 1/3 times n is the same thing as n over 3, so maybe you wrote it that way. So several different ways we can write it, but in every case, you'll notice that we've got p by itself on one side, and on the other side, the function is expressed in terms of the variable n. That is the only variable in the expression. All right, we have looked at how to use function notation with an equation, but what if they give it to me as a graph? Again, when you're using function notation, you're putting 4 in for your input value, like your x value, and you're seeing what you get for your output, like your y value. So when they say find f of 3, what they're saying is when x is equal to 3, what's your y value? Well, if you'll come over here and look on the graph, when x is equal to 3, you've got the ordered pair 3, 1. So when x is equal to 3, y is equal to 1. All right, look at another one of those, f of 4. So again, they're saying when x is equal to 4, what's y? So look at your ordered pair. So that looks to be about 4, 1/2. All right, then f of 0, when x is equal to 0, what's y? That looks to be about 2.5. And then f of 2, when x is equal to 2, what is y? And that looks to be about 0. All right, now we're turning this around, and notice that again, they're not saying find p of 3. They're not saying put 3 in and see what you get out. 3 is my output. So they're saying, hey, when your x value, or in this case your t value, if you're trying, what is that when your output value is equal to 3? Okay, so again, it's like the idea of saying when y is equal to 3, what is x? So again, we're working with t and p here, but sometimes it makes it easier for us to see when we work with x and y. So it would be like saying, hey, here's your y, here's your output. what was your x? What was your input? All right, so we're going to come up to our graph and we're going to look at where y is equal to 3. So when y is equal to 3, that's right here. So you can see that would be this point right here, which to me looks like 0, 3. And this point right here, which to me looks like 5, 3. Now, in the book, they were a little more precise, and they used negative 0.1 instead of 0 right here, and they used 5.1 instead of 5 right here. It would have been perfectly fine if you had said 0 and 5. All right, look at the next one. The next one says, where is the function equal to 0? So again, they're saying the output is 0. What's the input? So, okay, if I look at where my output is 0, then you can see, okay, looks like about 1/2 and 2 is where that's going to happen. And again, if I were writing that as ordered pairs, that would be 1/2, 0, and 2, 0. So that makes sense that that is where my values are equal to 0. All right, one-to-one functions. One-to-one function is a function whose inverse is also a function. So each output value has to correspond to exactly one input value. So you can't have x's and y's repeat. So we use the vertical line test to determine if we had a function, because in the vertical line test, it checks to make sure no two x values are the same. All right, if we want to find the inverse, if you remember when you solve for inverses, you switch x and y. So if I want to know if my original function has no two x values the same, and for the inverse I switch x and y, then if I want to check to see if my inverse is a function, I would want to be checking to make sure there were no two x values the same on the original. All right, so I could draw my original function and do the vertical line test, and then I could draw its inverse and do the vertical line test on that. But to save myself that work, I can look at my original function and do the vertical line test to make sure it's a function, and then if it is, I can do the horizontal line test to make sure that its inverse is a function. So for something to be one-to-one, it has to pass both the horizontal and the vertical line test. All right, for it to be one-to-one, it has to pass both the horizontal and the vertical line test. All right, so look at this first one. All right, is this first one a function? Well, does it pass the vertical line test? Yes. All right, is its inverse a function, meaning is it one-to-one? Well, if I do the horizontal line test, you'll notice it does not pass the horizontal line test. When I draw a horizontal line, it hits my graph in more than one spot. So yes, it is a function, but no, it is not a one-to-one function because its inverse is not a function. All right, look at the next one. All right, if we do the vertical line test, yes, it passes the vertical line test, and so yes, it is a function. It also passes the horizontal line test, so that means its inverse is a function, so it is a one-to-one function. All right, look at the next one. Does it pass the vertical line test? No, so it's not a function. If it's not a function, it can't be a one-to-one function, so there's no need to even check the horizontal line test. All right, look at the next one. Does it pass the vertical line test? No. It fails the vertical line test, so it's not a function, so there's no need to check as to whether it's one-to-one. All right, look at the next one. Does the next one pass a vertical line test? Yes, it does, so it's a function. Does it also pass a horizontal line test? No, I would hit the graph in more than one spot, so it is not a one-to-one function. All right, look at the next one. Does this next one pass the vertical line test? Yes, it does. All right, does its inverse, is its inverse a function? Well, the way that I can check that is the horizontal line test, and it does pass that. So yes, it is a function. Yes, its inverse is a function. So yes, it is one-to-one.